Friends, I am Dr. Prof.Chishty and I am teaching geometrical and physical optics to the BSc first year students. My today's topic is Hygiene's eyepiece. Now see what is an eyepiece. Eyepiece is used in the telescope. If we see the telescope, this lens is known as the objective lens, which is towards the object, and this lens is called as the eye lens, which is towards the eyepiece, means which is towards the observer. Now in this lens there is another lens, and the combination of these two lenses is called as the eyepiece. Means there are two lenses and these two are combinedly known as the eyepiece. So first we will study about the Huygen's eyepiece, construction of the Huygen's eyepiece. To construct the Huygen's eyepiece, you have to use here two plano-convex lenses. One lens L1, it is known as the field lens, and another lens L2, which is known as the eye lens. Now the focal length of this lens f1 is 3f and focal length of this lens f2 is f only. Now the distance between these two lenses are separated by a distance of 2f. Now if the objective lens, the rays which are coming from the objective rays are making the image after refraction through the field lens at a certain point here. This image is known as the I1 image. But if I extend these rays, objective rays, then the image will form at some another place. It is known as IO. Okay. Now the rays after refraction through the field lens will be allowed to incident on the eye lens, and after refraction through the eye lens, these rays become parallel. Here you can see the image. It means that the image will be formed at the infinity. Image is formed at the infinity. Here the image will be virtual image. Therefore this eyepiece is known as the negative eyepiece. This eyepiece is known as the negative eyepiece because this lens will see the virtual image of the object. Now whether there is spherical aberration or the chromatic aberration, so this eyepiece is free from the spherical and chromatic aberration. For spherical aberration, the condition is that D should be, distance between the two lenses should be equal to f1 minus f2. And if I take this as 3f minus f for this lens, so 2f, means spherical aberration is not there in this type of eyepiece. If I say that whether there is chromatic aberration, for chromatic aberration, condition is that D should be equal to f1 plus f2 upon 2. D means the distance between the two lenses, distance of separation. So D will be equal to 3f plus f upon 2. 3f plus 2f f upon 2, that is equal to 2f. Means here again the condition for chromatic aberration is satisfied. It means that this eyepiece is free from the spherical aberration as well as the chromatic aberration. Now you can find the equivalent focal length of this eyepiece, equivalent focal length. Now to find the equivalent focal length, I am having the formula as 1 by f is equal to 1 by f1 plus 1 by f2 minus d upon f1 f2. Lenses separated by distance d. So I will substitute here 1 by 3f, 1 by f minus d is 2f upon 3f into f. So here 1f get cancelled, and if I take the LCM, LCM will be 3f. 3f means here there is 1 plus here there will be 3 minus 2. So 1 by f will be equal to 4 minus 2, that is 2 by 3f. It means that the equivalent focal length of this lens system is 3 by 2 of f. 3 by 2 f. This is the focal length, equivalent focal length. Now after finding out the equivalent focal length of the lens system, we can find the cardinal points of this Huygen's eyepiece. Now to find the cardinal points, I will use the formula as alpha is equal to minus df upon f2 and beta is equal to df upon f1. That is the position of the first principal point, from the first lens, and the position of the second principal point from the second lens. So this is all about the construction and the working of the Huygen's eyepiece. Now the cardinal points of the Huygen's eyepiece. So I will write here the cardinal points of Huygen's eyepiece. Now to find the cardinal points of the Huygen's eyepiece, I am having the formula as alpha is equal to df upon f2. That is, d is 2f and f is 3 by 2f. We calculated it. f2 is 3f. So if I calculate the value of alpha, that is the principal point, first principal point from the first lens. So the 1f get cancelled, 3 get cancelled, 2 get cancelled. F2 is only f. So you will get here 2 get cancelled, ff get cancelled, and you will get here the value as 3f. So this is the position of the first principal point, that is the 3f from the lens number 1. It means that if the lenses are separated by a distance 2f, the distance between these two lenses is 2f, it is lens L1, it is lens L2, then the first principal point will be after this one, means plus 3f. So it is 2f and I will extend the distance f. So this distance is f. So this will be the first principal point. And a plane which is passing through the first principal point is known as the principal plane. Now I will find the second principal point. The formula for the second principal point is beta is equal to minus df upon f1. So minus d is 2f, f is 3 by 2f, and f1 is 3f. So I will get here the value of beta as ff get cancelled, 2 get cancelled, 3 get cancelled, only minus f. It means that the position of the second principal point is towards the left side of the lens L2, eye lens. Means from here, this distance is 2f. So here I will get the second principal point at the center between the two lenses. So a plane which is passing through the second principal point is known as the second principal plane. So these are the two principal points. Now where are the focal points? Let us calculate the focal points. To find the focal points, first focal point and the second focal point, I will use the formula as f1 is equal to minus f into 1 minus d by f2. Minus f into 1 minus d by f2. Now I will put the values minus 3 by 2 f, 1 minus d is 2f, and f2 is f. So here you will get as minus 3 by 2 f. 1 minus 2 will be minus 1. That is equal to minus minus is plus 3 by 2 f. Principal position of the first focal point. It is plus 3 by 2 f from the first lens. 3 by 2 means it is 1.5 f. 1.5 f. So this distance is 2f. So 1.5, that is 1f, and 1.5 will be here. That is here it will be f1, and a plane which is passing through the first focus is called as the focal plane. Now if I want to calculate the second focal point, I will use here the formula as f2 is equal to plus f into 1 minus d by f1. 1 minus d by f1. So I will substitute here the values as 3 by 2 f, 1 minus d is 2f, and f1 is 3f. So it is 3 by 2f into 1 minus 2 by 3. 1 minus 2 by 3. 1 minus 2 by 3 means 3 by 2 f into 3 minus 2, 1 by 3. 1 by 3. 3 get cancelled, and you will get here 1 by 2 f. Means f by 2 from the second lens. And this distance is positive. So we can say that from the second lens, if this distance is f, second focal point will be at f by 2. So this distance is f by 2. So a plane which is passing through the second focal point is called as the second focus. So second focal plane. Now, where are the nodal points? Because we are having the 6 cardinal points, 2 principal points, 2 focal points, and 2 nodal points. As the system is kept in air, lens L1 and L2 are kept in air. Therefore, we say that the nodal points coincide with the principal points. That is, N2 will be here and N1 will be here. So, nodal points will be coincide with the principal points. So, this is all about the Huygen's eyepiece. Huygen's eyepiece is a negative eyepiece. Now, what about the cross wire? If I want to use the cross wire, because the image is virtual here, if I place the cross wire at the object I0 or I, if I keep the cross wire between the two lenses, then the cross wire is magnified by only the lens L2, not L1. It means that there is unequal magnification of the image and the cross wire. Therefore, cross wire cannot be seen here, and we cannot use the cross wire. What is the cross wire? Cross wire is a mark in the eyepiece, with the help of which, cross mark in the eyepiece, with the help of which we can find the distance between the 2 points or distance of the 2 objects by focusing the cross wires, as in the binoculars or other optical instruments. So the necessity of the cross wire is for the measurements of the distances, but here in this eyepiece you cannot use the cross wire. Therefore, this is the another drawback of this eyepiece, is that it is using the virtual image, therefore the cross wire cannot be placed here. So this is all about the construction, working of the Huygen's eyepiece and the cardinal points of the Huygen's eyepiece. Thank you.